Alright, today our goal is to graph equivalent ratios and find ratios in a coordinate plane. This is something that we've already kind of done with two variable equations, right? Independent, dependent variables. Now, instead of that, there's just ratios. Hopefully, it's somewhat of a review, a little new. And what we're going to do to start off is review comparing ratios. So I have some problems that you need to do in your notebook. Okay? But when we compare ratios, we need to have a what? Liam. Gabe. If you write as a fraction, good. You need to have a common denominator, or your second one needs to be the same. Okay, so that you can compare. How do we get to equivalent ratios? How do you change them? Using what operations? Nikki?
Multiplication and division.
Good, multiplication and division. So I'm going to have some word problems here to compare ratios. Okay, what I'd like for you to do is, you and your partner, go ahead and read through the word problem, and I want you in your notebook to write the ratios, show proof whether these ratios are equivalent or not. Go ahead and start this one. Okay, so the ratios 5 to 10 and 3 to 5 are not equivalent because in simplest form you have 3/5 is in simplest form. 5/10 is 1/2 in simplest form. They are not the same simplest form, meaning they are not equivalent. Or you can have a common denominator of either 50, 10, and they are not the same. So these two are not equivalent. You good? Okay. Go ahead and we're going to hit no. Submit. Okay, try this one. When read to this, are the ratios the same or equivalent? So please put your calculators down, pencils down. I want you to look up here. What is one of the ratios that you got? Liam. The original ratio given to us. Good. So we have 9 over 15. And what's the other one? Samantha. Awesome. 12 over 25. Okay, question for you. Did anyone take 9 times 25 and 12 times 15? Did anyone do this? Please raise your hand if you did. It's okay. It's okay if you did. Please raise your hand. Okay. Those of you who did that, did you learn that like last year or 2 years ago? Yes, did everyone learn that? Jack? Third grade. Annabelle? Third grade. Paige? Did you do that? Okay. All right. Some of your teachers might have taught you this. It is a trick. It's a trick to get to your answer. Does a trick prove anything? Okay, a trick does not prove anything. So, a lot of people will use this method to get your answer quickly. It does not prove that they are equivalent or not equivalent. Okay? So, from now on, I will not accept it as showing your work because it doesn't prove anything. Does that make sense to everyone? If you were able to explain to me why they weren't equivalent, using that method, I would take it. But I don't even know how to explain why they're not equivalent. Or not equivalent, using that method. It is just something that happens to work every single time. Alright? Is everyone clear with that? Again, it's a trick that does work, so you're not wrong for doing it, and not wrong for doing it because one of your other teachers told you. But from now on, we have to prove our answers. Please give me a thumbs up if you're good with that, especially if you did it. Okay? All right, so to prove your answer, what are two things that we can do? One way is what, Liam? We can get a common denominator, or put them both in simplest form. Okay, let's do simplest form first. Is 9/15 in simplest form? No. Emery, what can we divide out?
We can divide 3 from the 9.
Good. And get 3. 15 divided by 3 is 5. That's simplest form. Okay, what about 12/25? Is that in simplest form? No, what can you divide out? Jack. Does 5 go into 12? No. We got whole numbers. Keep with whole numbers. Or integers. Okay? So no, it does not. 12/25 is simplest form. So, are these equivalent based off simplest form? No. Okay? What are some equivalent ratios that you got by having a common denominator? What did you do to both of them? What did we do to get a common denominator? Samantha? 15 by what? 15. This one we're going to multiply by 25. When we do that, what is the common denominator? What is 15 times 25? Kaden? 375. 375. What is 9 times 25? Okay? 225. What is 12 times 15? Samantha? 12 times 15? Anyone else have 12 times 15? Did anyone do it this way? Raise your hand if you did it this way. If you did it this way, please, participation. It helps out a lot other than you just staring at me. Okay? Annabelle? This is 180. 12 times 15 is 180. Do we all agree with that? Okay. I'm sorry. 180. Okay, I'll throw it off. Do we agree that's 225 over 75 and 180 over 375? Do we all agree with that?
Yes.
Okay. So, are these equivalent?
No.
No. They are not. Liam? Okay, good question. Can you do 9 divided by 15 and get a decimal point, and 12 divided by 25 and get a decimal point to see if they are equivalent? Yes, you can. Okay, but that's not the way that is asked. Okay, by using equivalent ratios. Whatever 9 divided by 15 is, your answer as a decimal is not an equivalent ratio. Does that make sense? Liam? Yes, it does prove your answer, so I'm okay with it. But if you need to write an equivalent ratio, you cannot do that. Question? All right. Okay, what we are going to do now is we are going to put ratios into a table, which we've already done, and then create that table and make a graph. So we are going to graph our ratios. We're going to start here at part 1.
The International Students Association is having a World's Fair. It takes the association 2 hours to make 3 flags for the fair.
A graph can help you see the relationship between
flags made and hours.
First,
First,
Okay, what I would like for you to do is create a table just like they have over here on the left-hand side. The ratio given to you is 2 hours to 3 flags. I want you to come up with 3 more equivalent ratios. Please show your work. Then graph those ratios in the graph to the right. Is there any questions on what you're supposed to do? 3 equivalent ratios, and then graph them in this graph over here to the right. If you want to talk to people around you, you may. All right, if the ratio is 2 hours, we can create 3 flags. What is an equivalent ratio to 2 to 3? Jordan, what's one?
4, 6.
4, 6. How do we get to 4, 6? Owen, multiplying it by 2. This is the work that I need to see. That proves to me that they are equivalent. What's another one? Sydney? 8 to 12. How did you get 8 to 12?
Multiply by 4.
Good. 2 times 4 is 8. 3 times 4 is 12. What is another equivalent ratio? Lila? 6 to 9. We multiply by 3. Okay. Now we can write the ordered pairs. This first one, the ratio, would be 2, 3. The second one, 4, 6, 8, 12, and 6, 9. You can go ahead and graph that then. Move this over. Okay. Let me graph it. 2 is our x, number of hours on the x-axis. 3 is our y flag. 4, 6, 8, 12. Have to go off the grid a little bit. 6, 9. What do you know is going to be true in your graphs if all the ratios are equivalent? What will your graph have? Jordan?
Straight line.
It will have a straight line. If all of your ratios are equivalent, you will create a straight line. We good with that? All right, what I would like for you to do then is I would like for you to go ahead and solve the next 2 on that front page. In your graphs on those 2 questions, the x and y axes are not labeled. Do you think you should label them? Yes, you need to label your x and y axis. The reason is, if someone were just to take that graph, they would have no idea what you're talking about if they're not labeled. If they are labeled, they could find your ratios and understand what the ratio means. So, if you're a little confused on what I'm saying, the x-axis right here, what does that represent? Hours or flags? What does the y represent? Hours or flags? Please write that on your guided notes. Okay, it says copy and complete this ratio table on paper, then graph the proportions of the table using the coordinate graph. Okay. So, if we in 3 hours make 2 flags, in 6 hours, how many flags are we going to make? Jack, thank you. 4. We get there by multiplying by 2. Multiply by 2. If we have 9 hours, how many flags are we going to make? Paige? That's 6. We get there by multiplying by 3. The x-axis is going to be represented by what? Gabe? Hours. Means the y-axis is going to be flags. That is going to be really important in your science career, that you label all of your axes when you graph. Okay? All right. 3 to 2. 3 up 2. Over 6 up 4. Over 9 up 6. Notice it is a straight line. All right, check your neighbor's last one. Check it out. Make sure you agree with each other. And we'll move on. All right, let's go to part 2 on the back. Now, this time, you are just given the graph. What I'd like for you to do is complete the table with the graph. So fill in the table. All right, 2 at a time. I'm going to go ahead and go over these. And this first one, your hours. What's the first one? Your hours, Kaden? 3, and that means your friend's hours would be, Samantha? 4. And your hours are 6. Your friend's hours are, altogether? 8. Your hours are 9. Your friend's hours are 12. Oh, perfect. Okay. Any questions on the next one? It should be 3 to 5, right? Then what? Jordan? 6 to 10. And the last one? Emery? 9 to 15. Awesome. Okay, last one here before we go. The International Student Association sells 2 flags for $4. How much money does it get for selling 3 flags? Show me proof using equivalent ratios. Have to use equivalent ratios. What is the ratio given? Owen. Good. 2 flags to $4. I'll say flags in money. How many flags are we trying to get to? Jack. We're trying to get to 3 flags. This takes multiple steps. I want you to look up here. Can we go from 2 to 3? Not with whole numbers. So what you do is, we find the simplest form. To make 1 flag, how much money does it cost? 2. How do we get from 1 to 3? Sydney? Multiply by 3. How much do they get for selling 3 flags? Caden? $6. Okay, so some of them will take, going back to your simplest form is helpful. Okay. All right, do the best you can on tonight's I15-1 homework. If you have questions, please let me know tomorrow.